So the question reads, let x be the number of ways. Oh, can you scroll down? Okay. Let x be the number of ways to rearrange the letters of the word Oompa Loompa such that the word contains POMO but not PMO. So POMO and PMO must be beside each other or contiguous substrings. So find the first three digits of x. So so essentially the solution goes like this. Okay. I'll state the answer later. If the rearrangement contains at least one POMO, then we have three possible kinds of words. Okay. So after um looking at the letters, you can see there's two P's, two M's, and four O's. So that could mean that wait. So that could mean that you can have two POMOs. Okay. You can also have one POMO and one PMO. Make sure you see why. Or you can also have one POMO or and zero PMOs. Okay. So let the let the number of ways we can rearrange them in each of these three cases be A, B, and C respectively. Then that will mean that POMO not PMO will be either A or C. So I'll highlight that. So these are the cases that we want. So so that will mean that x equals A plus C. Thus we can evaluate x by finding B and A plus B plus C. Because that way you can just do A plus B plus C and then subtract B. So essentially complementary counting. Are you good so far? Yeah, I guess we are. So, sige. Let's move on. So first let's compute B. So the word contains one POMO and one PMO. So treating POMO and PMO as contiguous substrings S and T, we rearrange the letters of wait. So essentially we let POMO be S and then PMO be T. Then that will mean that we rearrange the letters of this word because this one you can just replace with S and then and then this one you can just replace with T. So that will so we have two A's, right? So that means that we can do this in 6 factorial over 2 factorial, which is 360 ways. So B is 360. And then for A plus B plus C, that will mean that the word contains at least one POMO. So if we treat POMO as one continuous substring, then you can just replace these first four letters with S. And it will be this word, right? And we have so we have 8 factorial over 2 factorial ways. This is 10080. However, we have double counted the words which contain two POMOs. So we do complementary counting again. So oh, we subtract this word salsa. So reason for this, you just replace this one also with S. Alright? Do you have questions? Okay, wala. So and the number of ways we can rearrange this, there are two A's. Also here there are two A's, two O's. So this one will become 5 factorial over Oh, there's also 2s. 5 factorial over 2 factorial 2 factorial, which will be 30. So that will mean that a plus b plus c is 10050. Okay. Therefore, x is 10050 minus 360. So that's 9690. And therefore the answer is 969.